Ohm's law states that resistance is the ratio of voltage to current. In symbols, R is equal to V over I. This picture shows the relationship among the three electrical quantities, specifically the relationship between ampere and volt, and ampere and ohm, or in other words, the relationship between current and voltage, and the relationship between current and resistance, since current depends on both the circuit's voltage and resistance. The voltage causes the flow of electric charges throughout the circuit. Without this, there will be no current. Meanwhile, the resistance hinders the flow of electric charges. In other words, the resistance opposes current. These relationships can be mathematically expressed in the equation I is equal to V over R. In this equation, current is directly proportional to voltage. When the voltage increases, the current also increases, with the resistance being held constant. On the other hand, current is inversely proportional to resistance. When the resistance increases, the current decreases when the voltage is constant. The two electric circuits here have the same amount of resistance. However, they have different voltages. If this is the case, which bulb will shine brighter? The answer is bulb A, because in circuit A, the voltage is higher as compared to circuit B, and when the voltage is high, the current is also high. In the second situation, circuit A and circuit B have the same voltage, but they offer different amounts of resistance. In this case, which bulb will shine brighter? The answer is bulb A, because in circuit A, the resistance is lower than that of circuit B, and when the resistance is low, the current is high. Using the Ohm's law triangle, we can derive the equations for current, voltage, and resistance. If you are looking for the current, you just have to cover its symbol I, and you will get the equation I is equal to V over R. If you're looking for the voltage, just cover its symbol V to get the equation V is equal to I times R. And lastly, if you are asked to solve for the resistance, cover its symbol R, and then the equation will be R is equal to V over I. Here is the summary table of the three electrical quantities. In dealing with Ohm's law problems, we are going to use the Grassi method, wherein G stands for given, R for required, E for equation, S for solution, and A for answer. Problem number 1. An alarm clock draws 0.5 ampere of current when connected to a 120 volt circuit. Calculate its resistance. In this problem, we are given the value of current, which is 0.5 ampere, and the value of voltage, which is 120 volts. Since we are given the values of current and voltage, we have to look for the resistance. In getting the resistance, the equation that we have to use is R is equal to V divided by I. For the solution part, we just have to substitute the given values. R is equal to the value of voltage, which is 120 volts, divided by the value of current, which is 0.5 ampere. Dividing the two, the answer will be R is equal to 240 ohms. Problem number 2. If a toaster produces a resistance of 12 ohms in a 120 volt circuit, what is the amount of current in the circuit? In this problem, the given are resistance which has a value of 12 ohms and voltage which has a value of 120 volts. In this problem, we are given the resistance and the voltage, which means that we have to look for the current. The equation for the current is I is equal to V divided by R. For the solution, I is equal to 120 volts, which is the value of the voltage, and resistance, which is 12 ohms. Dividing the two, we will get the value for the current, which is 10 amperes. A small light bulb that is connected to a 6-volt battery draws 2 amperes of current. What is the net resistance of the bulb? Given, V is equal to 6 volts and I is equal to 2 amperes. The required quantity in this problem is R. To compute for the resistance, we just have to divide voltage and current. For the solution, R is equal to the value of voltage, which is 6 volts, divided by the current, which is 2 amperes. The answer is 3 ohms. A motor with an operating resistance of 32 ohms is connected to a voltage source. The current in the circuit is 1.5 amperes. What is the voltage of the source? The given in this problem are R, which has a value of 32 ohms, and I, which has a value of 1.5 amperes. The required quantity is V. To compute for the voltage, the equation that we have to use is V is equal to I times R. For the solution, V is equal to the value of I, which is 1.5 amperes, and the value of R, which is 32 ohms. Multiplying the two quantities, we'll get the value for V, which is 48 volts. Determine the amount of current going through a 50 ohm resistor with a voltage of 120 volts. The given in this problem are the value of the resistance, which is 50 ohms, and the value of the voltage, which is 120 volts. The required quantity is the current, which has a symbol of I. For the equation, I is equal to V divided by R. In the solution part, we just have to substitute the values, wherein the voltage is 120 volts and the resistance is 50 ohms. Dividing 120 and 50, we'll get the value of the current, which is 2.4 amperes. An electric heater works by passing a current of 100 amperes through a coiled metal wire, making it red hot. If the wire's resistance is 1.1 ohms, what voltage must be applied to it? For the given, we have the current, which is equal to 100 amperes, and the resistance, which is equal to 1.1 ohms. In this problem, we have to look for the voltage. And the equation for the voltage is V is equal to I times R. For the solution part, we just have to multiply the values of the current and the resistance, and that is 100 amperes multiplied to 1.1 ohms. Multiplying this two, we'll get the value of the voltage, which is 110 volts. A 2.5 ohm electrical device draws a current of 6 amperes when connected to a 15 volt source. If it is connected to a 12 volt circuit, how much current will it draw? The only given quantities that we need in this problem are the following: the amount of resistance, which is equal to 2.5 ohms since we're dealing with the same electrical device, and the new value of voltage, which is 12 volts. Since we're given the resistance and the voltage, we have to look for the current. The equation in getting the current is I is equal to V divided by R. For the solution part, we just have to divide 12 volts and 2.5 ohms. Dividing these two measurements, we'll get the value of current, which is 4.8 amperes. The current passing through a resistor in a circuit is 0.02 ampere, when the voltage across this resistor is 5 volts. What current passes through this resistor when the voltage across it is doubled? In this problem, we are given the value of the initial current, which is 0.02 ampere. We are also given the value of the initial voltage, which is 5 volts. And lastly, the value of the final voltage, which is just twice the amount of the initial voltage. The actual required quantity for this problem is the current. But before we compute for that, we have to compute first for the resistance. The equations that we have to use are the following. In computing for the resistance, we have to divide the initial voltage and the initial current. And after we get that, we have to compute for the current. And that is final current is equal to final voltage divided by the computed resistance. Solution A. R is equal to the initial value of voltage, which is 5 volts, and the initial value of current, which is 0.02 ampere. By dividing the two, we'll get the value of the resistance, which is 250 ohms. We have to use this computed value to compute for the value of the final current. Final current is equal to the final voltage, which is 10 volts. Divided by the computed value of resistance, which is 250 ohms. When we divide this two, we'll get the value of the current, which is 0.04 ampere. The final current when the voltage is doubled is 0.04 ampere. To make things shorter, we can just use our logic. In the problem, it was stated that the voltage is doubled. By using Ohm's law, we can say that the voltage is directly proportional to current, which means that as the voltage increases, the current also increases. And when the voltage is doubled, the current should also be doubled. To do this, we just have to multiply the initial value of current, which is 0.02 ampere, to 2. The final current is equal to the product of 0.02 ampere and 2, and that is 0.04 ampere. This is the same as the one that we computed in the first part. Problem number 9. What happens to the current in a 5-volt circuit if a 10-ohm resistor is removed and replaced by a 20-ohm resistor? The given in this problem are the value of the voltage, which is 5 volts, the initial resistance, which is 10 ohms, and the final resistance, which is 20 ohms. Since we are given two values of resistance, we have to compute for the initial and the final currents. In getting the initial current, we have to use the equation I sub 1 is equal to V divided by R sub 1. For the final current, the equation is I sub 2 is equal to V divided by R sub 2. Initial current is equal to 5 volts divided by resistance 1, which is 10 ohms. By dividing these two, the initial current's value is 0.5 ampere. For the final current, we just have to divide 5 volts and the value of the second resistance, which is 20 ohms. The value of the final current as computed is 0.25 amperes. By comparing the initial and the final currents, we can say that the final current is half of the initial current. Another way to solve this problem is using our logic. First, we have to analyze the two values of the resistance. As we can see, the resistance 10 ohms becomes 20 ohms, which means that the resistance here is doubled. By following Ohm's law, we can say that the resistance is inversely proportional to the current. That is, when the resistance increases, the current decreases. This only means that when the resistance is doubled, the current should be halved. And the half of the initial current, which is 0.5 ampere, is 0.25 ampere. Problem number 10. What happens to the current in a circuit if a 1.5 volt battery is removed and is replaced by a 3 volt battery? Note that the effective resistance in the circuit is 6 ohms. The given in this problem are the initial voltage, which is 1.5 volts, the final voltage, which is 3 volts, and the value of the resistance, which is 6 ohms. In this problem, we are given two voltage values. This implies that we have to compute for two values of current, and those are the initial current and the final current. In computing for the initial current, we have to use the equation I sub 1 is equal to V sub 1 over R. And for the final current, we have to use the equation I sub 2 is equal to V sub 2 over R. Initial current is equal to the value of the initial voltage, which is 1.5 volts, divided by the value of the resistance, which is 6 ohms. The computed initial current is 0.25 ampere. For the final current, we have to divide the final voltage, which is 3 volts, and the resistance, which is 6 ohms. By dividing the two, the final current will have a value of 0.5 ampere. Now, we have to compare the two values. The initial current is 0.25 ampere and the final current is 0.5 ampere. By analyzing this, we can conclude that the current is doubled. We can solve this problem by simply analyzing the values of the initial and the final voltage. From 1.5 volts, it becomes 3 volts. Here, we can say that the voltage is doubled. By following the concept of Ohm's law, which states that voltage is directly proportional to current, we can say that when the voltage is increased, the current is also increased. So when the voltage is doubled, the current is also doubled. And when you double the initial current, which is 0.25 ampere, you will get the value for the final current, which is 0.5 ampere. Drop a comment if you have questions and you want to add some essential information. Thank you.